Don't trust no chicken messing with your dog. That law.
You heard it. That's what we'll be working on today, the exponent laws. We will begin today with P.2, which is chapter P from our books. We're going to be looking at the additive law of exponents first, which I like to call ALLO. So, how ALLO works says that if I take some power with base B and I multiply it to another power with base B, that's the same thing as me saying this is b to the x plus y. Now, why the heck does that work? Let's check it out. So y. So let's say I have 4 squared times 4 to the third. That's equivalent to 4 times 4 times 4 times 4 times 4 times 4, which is 4 to the 5th power. What do you know? All I had to do by ALLO is add 2 and 3. Thank you, exponent law, ALLO. All right, let's move forward to power of a power, pop. We're literally taking the power of a power. So if I have b to the x and I actually want to raise it to the y power, that's equivalent to b raised to the x times y power. Woohoo! Why the heck does that work? If you haven't noticed by now, I like to figure out why things work. So if I have, let's use 4 because 4 is a beautiful number. 4 squared raised to the third power, that's the same thing as me having 3 factors of 4 squared. So that's 4 squared times 4 squared times 4 squared. Check it out. This is ALLO again, which is the same thing as 4 to the 2 plus 2 plus 2, which we all know is 6. Whoa! Okay, let's continue through. Let's look at separating the base, aka products raised to a power, what I like to call it STB. How does STB work? Well, it states, let's change the color up. What are we saying? Orange. Let's do orange this time. Okay. Let's say that I have 2 different bases. So let's say I have A, B, and I want to raise that all to the x power. STB tells me that I'm basically separating the base. So I'm doing A to the x times B to the x. These are equivalent. I'm not going to tell you why. You will later on tomorrow or later on in class. All right. Next up, we have division of exponent laws. Dale, what? Dale. All right, not the computer, but you know, this only has one L. So Dale tells me if I have, so let's say I have b to the x over b to the y. That's the same thing as b to the x minus y. And of course, I like to know why things work, but you all are going to show me. All right. Next, we have a quotient raised to a power, which I like to call Q-tap. So I'm actually going to take a quotient. Let's change up our color again. Let's say I'm going to have, let's say we have A over B to the x. That's the same thing as A to the x over B to the x. Again, continuously think, why do these work? Why does this work? Negative exponent law, I like to be positive, but so does the exponents. So, for instance, if I want to have a to the negative n, to make it positive, I have 1 over a to the n. Or another way to look at this, get the heck out of here. Okay, if I have a to the negative n, 1 over a to the negative n, it's the same thing as a to the n. Wow, this is craziness. How in the heck is all this stuff working? That's what I want you all to tell me later on. So, then we have Zell. We added DA. We have my favorite game of all time, Zelda. The zero exponent law, which states that if we have some base raised to the 0 power, it is 1. What in the heck? Just 1? think about when does this, is there any exceptions to this rule? And why does it work again? Okay, at this time, I would ask for you to pause the video and try checkpoint 1, which are these problems here. And as soon as you restart it, you will see the answers pop up for each of these here. I hope this was helpful. Have a wonderful day. Voila, here are the answers. Hope it was 100%. If not, hopefully you can pinpoint what you need to work on. That's law. We out of here.